Okay, in a previous video, we looked at taking a directed adjacency table, weighted adjacency table rather, and producing a graph. And now I'm going to use Kruskals algorithm. And what this is looking for is to connect up all the vertices, so all the points here, with each other, but in a tree, so there'll be no loops. And what he says that I need to do is start with the minimum possible edge. So I've got an edge of 2 here. I've got one more edge that I need to draw in there. E to F is also 2. So I've got one edge there, which is B to D, which is 2. I've also got E to F, which is also 2. So I'm also going to have that 2 there included. So far I've got this edge and this edge. And then I'm going to look for all the weights of 3. So I can go from A to E, I can go from A to D, and I can go from D to C. And they've all got 3s. Next I'm going to look after the 2s, the 3s, look for the 4s. So using Kruskals, I want to do that. However, that has now made a loop. And I don't want any loops because I want to have a tree. So I don't want that 4 there. So if you find you're going to go back and make a loop, you don't include it. So there are no other 4s. There's a 5 here, but that will make a big loop all the way around like this. So I don't want that 5. Now I can produce a 5 here that connects F to G, and there's no loop. And I can do D to G, and there's no loop. I can do either. So this is also going to show you that it doesn't matter which one I do. So there's 2 different answers for the minimum spanning tree, but they'll give the same weight. Now I've connected A with B, with C, with D, E, F, and G. They're all connected up together. So what I'm just going to do now is draw out that minimum spanning tree. So A is connected to E with 3, and then E is connected with F. Maybe I should just draw on there what these are. So that's A and E and F, and that connection there is a 2. And then F connects to G with a 5. Let's put a little vertex in there for F. And A connects with D. D connects with B. And A to D is 3, and D to B is that. So you can see here that we're producing the minimum spanning tree. I've got A, B, I haven't got C. C and D are down here, so C is here. And that one is 3. And now we're all connected up. And the minimum weight is just to add all these up. So 3, 6, 8, 11, 13, and that last 5 is 18. So that's my minimum spanning tree using Kruskals algorithm.